Okay, one other thing you're going to need to know for your test, or for any other subsequent thermochemistry tests or quizzes, is how to calculate the delta H at standard conditions for certain reactions, given the delta H of formations, which is our delta H with a little degrees symbol on the subscript F. That just means that's our delta heat of formation. And what that tells us is how much energy is required to form these different compounds. So using our delta H of formation, our energy required to form the compounds within a reaction, we should be able to calculate the delta H for the entire reaction. So that's exactly what this problem is asking us to do, to calculate the delta H for the entire reaction using the individual delta H of formations for each of the compounds involved in the reaction, both our reactants and our products. So if we notice, our delta H of formation is in kilojoules per mole. So each of these numbers is going to tell me how many kilojoules is required to form 1 mole of the substance. So for example, it takes, when we form NH3, when we form 1 mole of NH3, it's actually going to release 45.9 kilojoules. When I form NO, I'm going to absorb 91.3 kilojoules. I know that I'm going to absorb or release based on whether it's a positive or a negative. If it's a negative, I'm actually going to release heat in the formation of the compound. If it's a positive, I'm going to be absorbing energy in the formation of the compound. So the equation that we need to know, and this is again one of those equations that I would write right at the top of your test as soon as you get it, right after you write your name and you write your solid to liquid to gas and your delta H, vap, solid, fusion, condensation, I would write this equation, which is delta H for entire reaction, that's what RXN stands for, is the delta H fusion, oops, that's not very clear. Let's try that again. Fusion of our products minus the delta H fusion of our reactants. Again, that's an F, not a T. Okay, so how we use this is, as I said, each one of these is for 1 mole. So for our NH3, we have 12 moles. So I need to multiply negative 45.9 times 12. And when I do that, I get negative 550. So then I'm going to move down my equation and convert all of my delta H fusions for each of my compounds so that they represent the delta H of fusion for the correct number of moles. So for my oxygen, my delta H of fusion is actually 0 because my Brinkelhoffs, remember BRINCLHOF, my Brinkelhoff, all of these elements are diatomics. When they exist in a gaseous state, they're in their standard state, which is a gas, they're going to exist in pairs. So Br2, O2, F2. Okay, so we're not really going to form them, so there's no real formation energy involved. That's also going to be true if I have a single element. We don't form elements, God forms elements, so there's really no heat of formation for a single element. So my delta H of formation for carbon would be 0. Okay, so just kind of keep that in mind. So that's why our O2 is 0, because it's a Brinkelhoff and it's in a gaseous state. So there's no heat of formation. So I'm going to do negative 550 plus 0 times 21, which is 0. And then for my products, I've got negative 133.9 times 8, which is actually negative 1071.2. And careful, watch your negative and your positive signs. So for my NO, I'm actually going to do positive 91.3 times 4, which is going to give me positive 365.2. And then for my H2O, for my water, I have negative 241.8 times 14, because I actually have 14 moles of water. So negative 241.8 times 14 equals negative 3,385.2. So now I'm going to add my reactants and my products up. So this is going to be negative 550. And for my products, I'm going to get negative 4,091.2. Now that I've done all that math, I'm just going to simply plug and chug into this equation right here. So let's change colors one more time. My delta H of my reaction at standard conditions is my delta H of formation of my products, which is negative 4091.2, minus the delta H of formation of my reactants, which is a negative 550. So it's really going to be negative 4091.2 plus 550, which is going to give me a delta H of reaction for my reaction of negative 3,541.2 kilojoules, right? Because my delta H of formation up here was kilojoules, so this also needs to be kilojoules. And that's it. That is your answer, your delta H of your reaction. And that little degree sign just means standard conditions. Okay? So that's how you would figure out one of those equations. Multiply your delta H of formations by your moles, add up your reactants, add up your products, and then subtract your reactants from your products.